myself Professor Gautam Das. I will be discussing today or kickstarting the new course called Communication Network, and I am actually associate professor from G.S. Channel School of Telecommunication, IIT Kharagpur. So, what we will do is we will initially give a basic introduction of this particular course. What are the things we should expect from this course, and why this communication network is important, what are the problems it is solving, and why it is in which direction it is going. So, that is something we will give, and briefly we will actually go through the course. So, let us see what we mean by, first we have two terms actually, communication and network. Let us first talk about the communication. So, if you see this diagram over here, so initially communication started with mostly voice communication. So, in voice communication what happens, you say something and that has to be communicated to somebody who is distant, means far away from you, and it needs to be some methodology has to be implanted, so that we can actually this information that you are trying to transfer to the other party, that can be transferred faithfully and reliably. So, what do we do? Generally whatever you let us say voice, so whatever you talk, that initially the first thing is a transducer. So, what that will do, that will convert your sound energy into a electrical signal. Okay. So, first that transducer is the first part, which actually converts any of the things, information that you have to transfer to a corresponding equivalent electrical signal. Okay. So, that is the first part. Now, it can be image also, it can be video also, it can be any other digital form that is coming out of your computer. So, all those are information actually, those information will be accordingly converted to, means you enter something from keyboard. So, that is also some information. So, that will be finally what will happen, it will be converted to a corresponding electrical signal. So, that is what happens after the transducer. So, once it is, the output of the transducer will be some electrical signal. That electrical signal can be of any form, that might be if you are entering from a computer keyboard, probably that will be a digital signal. If you are, it is just pure voice and you are converting to a electrical signal, then it will be analog signal. Okay. So, that means the values or the voltage correspondingly that will be generated, that can take any value, whereas if it is digital, then it can only take discrete values, discrete levels. So, these kind of signal can be generated. So, whatever signal will be generated, that can have different forms, but whatever it is, that information has to be transferred. So, for communication what you do, then we all have done basic communication courses. So, you actually will be doing modulation, demodulation, means actually modulation when you are transmitting. So, that should be the modulation block. Why I have shown modulation, demodulation, because it is a two-way communication. So, if you are trying to connect to somebody, they might also send something. So, basically the first block should be the modulator. So, it will modulate. Why we do modulation? So, those are part of the communication course that you have already done probably. So, that is what I am assuming. So, you do modulation, purpose of modulation is all well known, and then after modulation the signal is transferred to the channel through which the signal will be going. So, if it is a wireless channel, then it will be through antenna. If it is some other things, accordingly you will be putting your you will be launching them. So, if it is optical fiber, then it has to be some laser modulated and then launched into the fiber. So, if it is coaxial cable, accordingly you will be doing. So, whatever be that, so there should be a channel, then in the other end of the channel. So, now the channel will be carrying the signal. So, in through some electromagnetic wave. So, if it is wireless, it will be electromagnetic wave through means unguided media. So, it will be propagated. If it is some coaxial cable or optical fiber, it will be guided electromagnetic wave, which will be going to the other end. Okay. So, in the other end you take that signal again, if it is wireless through antenna, if other things wired media. So, accordingly you will be taking that. Then what you do demodulation, the reverse operation. So, you have modulated the signal, you demodulate it. Once you have demodulated, you get the original form of the signal. Of course, in between you will be doing all those things, because you want to faithfully do the communication. So, therefore, to keep the information intact, you have to do some more things. So, that we all know we do a different kind of encoding, source coding, channel coding. So, all kinds of things are there. But once you do this demodulation, you do all those aspects of demodulation, and then after that you actually give it to the transducer one more time. So, transducer will be actually reverting back what you have done in the transmitter side. So, it will be reverting back, it will be again converting it into let us say if it is voice, then sound energy. So, basically sound these things it will generate, and then it you get to listen to what has been told on the other side. So, this particular communication is up, we call it point to point communication, as I am mentioning over here. So, this is called a point to point communication. So, from one particular originator or source to another destination. So, this part has been covered in your communication courses. Now, what we want to see is this communication, how it goes into networking. So, this is the part we will be mostly discussing in this particular course. Okay. That should be our major prime concern actually. So, now we know through communication that from one particular point to another particular point I can always transmit. So, this is something we already know. Now, what we have to see is from there this particular networking thing, where from it comes. So, let us try to see. So, whenever you are doing this kind of communication, is it that in this world only two fellows will be talking to each other at a particular time? Probably not, that will not be the case. Multiple people are there, multiple machines might be there which wish to communicate to other people, other machines, and the requirement will be keep on changing with time. So, let us take this example of this 4 node, this one. So, let us say these are 4 entities who wish to communicate to each other. Okay. Now, the problem is if we just say this is probably let us say this is node A, this is node B, so C and D. So, now at a particular time what might happen, A wish to communicate to C. So, that is like this link. Okay. So, at this point A, this is A and this is B. So, that kind of communication. So, this is a point to point link which is required at that particular instance. But what might happen at the same time, B might wish to generate another link to D. This is possible because A is already talking to C. So, A and C are occupied already, they are talking to each other. Now, B and D are free, they might also wish to communicate among themselves. So, this is a possibility, and this is something which you have to facilitate, because you cannot say that just because in this world A is talking to C, therefore, nobody else can communicate. So, that is a restrictive service and we do not want to give that kind of service. So, if this is our requirement, then I have to make arrangement to do this. How we can do? So, basically what we can do right now, what we can see that maybe if this is the requirement A to C, I can construct this kind of communication link. So, transducer followed by modulation, then the channel will be there, whatever channel will take. If it is a fiber, then we will lay fiber from A to C, probably then the modulator and then another transducer. Okay, A and C can talk. Now, B to D you have to give. So, another such kind of link you put. But what might happen, it is not restricted that A will be only talking to C. So, A might wish to talk to B at some other time, some other point A might wish to talk to D. So, similarly B can also try to do, and so C and so D. So, if everybody wish to communicate to each one of them, so what I need to do is, now we can understand. So, this kind of point to point communication link we have to construct among themselves. So, everybody should have these kind of links. So, all these links has to be constructed. Immediately what we can see, that point I want to emphasize, that there might be this kind of NC2 kind of, if N is the number of nodes which are there. So, NC2 combination will be coming into picture. So, that many communication channel has to be given, point to point link has to be given. So, if for our case it is 4. So, 4 C2, immediately we get 6 links. So, as you can see, I have constructed 6 links over here, and those 6 links has to be exclusively given. But now let us try to see what is happening. I can probably provide these links, but remember these links are really costly, because you have to, suppose if it is laying fiber, you have to lay fiber over there. Okay. If you are laying coaxial cable, so you have to lay coaxial cable. They are, remember this A, C, B, D are physically means distant. So, basically they are located in different places. So, for each and everybody and each and every machine, if I have to construct this kind of point to point link, that will be very costly. Remember, the cost is okay, we can still go towards the means costlier solution if we get return to that. So, let us try to see the scenario that I have constructed these 6 links, but what will be happening? Suppose the time A is communicating to C, at that time let us say B is also communicating to D. So, that is the maximum things that can happen, all 4 parties are already engaged. So, what is happening at that instance, how many links are getting actually activated and being utilized? Only 2 links, A to C links, B to D links. All other 4 links, this and this are not utilized. And this is, remember, this is the best case scenario, that means all 4 are involved. If all 4 are not involved, suppose in a particular scenario only A is talking to D, that is the only link which will be activated and all other 5 links will not be activated. So, this is a scenario which will be happening. So, most of the time all the infrastructure that you are building with some huge amount of cost, that is getting wasted, that is not getting properly utilized. So, as an engineer, you have to think about utilizing them properly or reducing the infrastructure, whereas we should not compromise on the kind of service that we want to provide. That means, if A wish to talk to C, I have to immediately provide a communication channel between them. So, this particular, or A wish to talk to D, immediately I have to construct a communication channel between them. So, this particular requirement I should not compromise, because otherwise the service will be compromised. So, I do not want to compromise the service, but what I want is, I want this resources that we are putting upfront, that must be more utilized. So, that is the design where communication network comes into picture. So, in the entire course we will be trying to show how efficiently we can design these particular aspect of communication network. So, this is actually called network. Network means multiple entities, among them you want to give a communication channel, so that anybody at any time wish to communicate to any other party, they are capable of doing that. It is a flexible communication network that you are providing, so that anybody can freely talk to any other, and the service is being provided by this network infrastructure that you are building. And now, as an engineer, our task should be how efficient or how cost effective we can make it. So, that should be our target. So, let us see one way to make it cost effective. So, let us try to target that, can we make it a cost effective network. So, what is the one way of doing that? One way of doing it is, instead of putting this 6 links, let us put some central node which we are calling right now as switch. Let us call a switch or hub or anything you can call. Okay. Whatever it is, it is a new entity. So, there were 4 nodes, node A, B, C means A, B, C, D. So, those 4 nodes were there. So, right now what we are doing, we want to give connectivity among themselves. So, in between I put another node. Okay. This is not an active node, he does not have a communication need generally, he is the facilitator. So, he is part of the infrastructure. So, I put that infrastructure and then I actually connect all the nodes to him. So, basically I connect all these 4 communication link. Okay. So, what is now happening? Immediately you can see. So, if NC2 connectivity were required earlier, with this configuration I only need N connectivity, that scales very nicely, it scales linearly, whereas this scales exponentially, right. So, basically as the number of node increases, huge number of connectivity will be, means I should not say exponentially, it is actually quadratic. NC2 will be n into n minus 1, right, divided by 2. So, it has a n square term. So, it is in a quadratic fashion it increases, whereas this is increasing with respect to n in a linear fashion. So, I actually give this connectivity, but now let us see whether all those facility that we wanted to give or we wanted to provide, that kind of flexibility of anybody can talk to anybody at any time, can we provide that. So, for that this switch has to be designed properly. Okay. So, what we are trying to facilitate over here is something like this. So, at any time this switch should be a reconfigurable one, so that if A wish to communicate to C, then the switch must give this connectivity. So, switch must be something like this, okay, where this is A and let us say this is B. Of course, it should be a little bit different, we will talk about that later. Right now this should be sufficient. So, if A wish to communicate to C, it should be this. If A wish to communicate to D, it should be like this. Okay. So, if we want to make this 4 cross 4, so everybody can communicate to everybody. So, what I should do is something like this, all A, B, C, D. So, basically A, B and C and D I put, and then they will be also connected to all A, B, C, D. So, all 4 basically, and then this switch I can configure. So, this is a configurable switch where with an instruction A can be connected to B, A can be connected to C, A can be connected to D. You later on will be discussing about how these switches are designed. So, all those things we will be discussing later on, but right now this should be sufficient to understand that I will be providing this connectivity in a flexible manner. So, whoever wish to connect to whoever, that flexibility I will be providing. If I can do that with that switch, then my purpose is served, because now I can always connect to anybody according to the requirement. So, basically the user has to tell this. What I will talk about over here is a nice story which has happened for the initial days of telephony networking. So, in telephony networking, what used to happen earlier, so suppose in a locality there are like this. So, 4 users are there, let us say. So, those 4 users wish to connect to each other. So, first option was something like this, 4C2 all 6 connectivity you give, but that was costlier, people understood that. So, at that time what happens, so they wanted to provide this switch. So, instead of switch, what they did was a operator room. So, where physically a operator was there. So, whenever A wished to talk to somebody, he used to call the operator. So, first option is you first talk to the operator. You might have seen those earlier movies from 1940s or something. So, you might have seen that people used to call to the operator, and then they used to tell to the operator that in this locality I want to talk to this. So, suppose C or B or D, whichever he wants to talk to, then operator manually used to connect them. So, basically there were this connection facility for A, B, C, D, and there were connection facility, and these links were going to A, these links were going to B, and so on. So, basically operator used to with a jack used to connect them. So, whenever he listens to A, then he sees whom A wants to, and then he used to connect them. So, this used to happen. So, this was a kind of manual switching that used to happen at that time. That is still a switching. You can see that number of links will be reduced. So, means every user has to connect to that operator room. So, as many users are there, that many links will be there, and then operator has to do that. So, with that there was a funny story. So, this what happens, there was a guy named Strauzer who was a undertaker at that time. Okay. So, he used to get his business for doing this all funeral services. Okay. So, what used to happen, he used to get calls from all the other parties from the locality, and then he used to take that means provide that service. So, what happened, suddenly he for some time being he started observing that his business was down. So, he was not getting enough calls. He then started inquiring what has happened, whether my service was bad or people are not happy with my service. So, they started looking into that aspect. Then after inquiring, he could see that there was a lady who was the operator, and that lady was actually she was the wife of another competitor of him. So, another undertaker actually in that locality, and what that lady used to do is whenever she received a call for him, for Strauzer actually, that that particular one wants the service of this guy, then she used to divert that call to her husband. So, this was the thing which was happening. So, that is probably the first case of corruption that you could see, you could observe due to manual operation, and that is one of the solution. We are talking about digitization to take out corruption in India and all those things. So, it just this story actually, it is a funny story, but it suffices, and this was the first engineering decision probably which has made means eradicate corruption from the system. So, what Strauzer did, he thought okay, and he was a knack of engineering, he was having that knack. So, he started thinking that okay, I'll get rid of this manual operation, I want to make this particular thing means automated. So, he started building that automated switch, which means a version of that is already there in these days telephony. Basically, he was the father figure of developing that. So, he was in a separate business, he started developing because he wanted to save his business. So, he started making it automated. So, that is when the switches started becoming automated, and now the automated version you see that you dial a number. So, basically if older days phone, if you see, they used to dial a number, some 9 digit 10 digit number. So, with that number it used to go to the switch, switch was automatically seeing those numbers where it wished to reach. So, it used to configure which port to which port it has to be connected, means it has to make the connection, and automatically the connection was made. So, that was the story of Strowger, who was the first to actually make it automated. But whatever that story is, this is just a nice story, nice anecdote towards how switch becoming or network started becoming automated. So, these days we are talking about cognitive networking, network with artificial intelligence, or network with intelligence, or intelligent networking. So, this is all started at that time in old age telephony switching itself. But whatever that is, so we have now understood that how the networking was coming into picture, at least in those days in telephony networking, and what is the requirement of means making the network more efficient. So, as now you can see what is happening, this is taking out the scalability issue, this part, and this is also reducing the wastage of resources. So, these are the two things which are happening due to this invention. Okay. So, if we just, so all right, so from there let's continue on that journey of this telephony network actually. So, if we just see, this is a kind of overall network that used to happen on those days. These days also it is still there, telephony, old telephony network is still something like that. So, basically there is a local subscriber loop. So, where all the users used to connect to a particular this local subscriber loop. So, from there used to go the trunk switch, will means trunks. So, trunks are actually aggregating all this. So, if somebody from a particular area is communicating to somebody else, suppose this is my node 1, sorry. So, means whatever we have discussed so far, so we could understand why communication network is so important. So, if we just give one example, of course, we will go into the details of this example. So, how a telephony network. So, in the chronology of all the networking, telephony came first, and that was the network which was extensively tried out and deployed. So, how that came into picture. So, and what are the salient feature of that particular network, we will try to appreciate that first. So, there what used to happen. So, basically initially telephony network was within a locality. So, within the same locality like Strowger's case I was talking about discussing, but basically the networking cannot be restricted to within a locality. So, its success was because we could connect them globally. So, for that I need to construct a global network. So, therefore, the local part of the network, which is this part, so that is one of the part, okay. But I have to actually multiple such locality I have to connect. So, that is where this particular thing comes into picture. So, there is a switch which is the local subscriber loop, probably we can call it switch, we can call it multiplexer, we will talk about that later on. So, there is switching plus there is also multiplexing. So, we will talk about that later, but whatever it is, let us for the time being let us take it as switch. So, you have a local switch, but between local switch also you have to give connectivity. So, that is what the trunk switch does between different localities. So, we have constructed locality A, locality B and locality C. So, you can have all these trunk links between this locality to a trunk switch. So, it is a hierarchical thing. So, basically what we are trying to do is we are generally multiple users we are connecting to a switch, then everywhere multiple users are getting connected to a switch, okay. and then among the switch again we are constructing a network. So, basically this switch has to communicate. So, if there are 3 or 4 switches, then again we put another switch and they connect to all these switches. So, this is how in a hierarchical manner, in a tree or mesh fashion, partial mesh fashion, we will be actually connecting everybody. So, then it might happen that you have to not only take decision at one switch, but you have to take decision in successive switches. So, let us say a particular guy A who wish to communicate to another guy A dash over here. So, he has to configure this switch, so that his connectivity goes into this. Then from this switch that connectivity has to be configured, and this switch also that connectivity has to be configured. So, it is a series of switch where you have to actually make the connectivity properly constructed. Okay. We will see how the switch operates and how do we make connectivity among switches. So, these are the things in details we will be seeing later on. So, this is the particular part. In the next class probably what we will try to do, we will try to discuss about the features of these things, how philosophically this was constructed, what is the basic feature of these particular kind of switching, how it is different from today's switching, and what other shift, paradigm shift that has happened in terms of this data transfer and switching and all those things. So, we will try to appreciate that in the next class. Thank you.